we're going to look at the refraction of light. When we talk about refraction of light, and again, light is an electromagnetic wave. It's the bending of a light wave as it passes through a boundary between two substances, and this is the key part, due to a change in speed. You have a change in speed here. In other words, it's either slowing up or it is moving faster. So let's see if we can do a quick little diagram here. And let's say we've got air up here, and this is water. This explains why quite often you try to grab something in water, it's not where you think it is. Oh, in middle school you probably did the old, looks like put the pencil in the clear glass of water and looks like it's bent in half. Well, the whole idea here is that is the refraction of light. And let's see. So we always put a normal in here so we can see what's happening. So let's put the normal in here so we can look, have something to measure here or look at. And let's have a wave coming in from the air. Yeah, let's do this one here. Let's see if we can do this color. And if I can get that color. There we go. So we have a wave coming in, through the air. And it strikes this interface here. So it forms an angle here. But as it hits the water, it bends or is refracted. And this angle here, again, from this normal to the ray is going to be less than this angle up here. What really happens is this change in speed. When you guys start driving, all of a sudden you get two wheels on the road, two wheels in the gravel, and your car wants to lurch to the gravel side. It wants to refract. If you ever try to run along the beach, have one foot on the concrete and then one foot in the sand, you always want to move to the area in the sand. That's really refraction. And so this is the big part, due to a change in speed. We're going to look at Snell's law in the next video, but right now let's take a look at a couple different types of lenses that are fairly common. The first lens we're going to look at is a concave. And again, when you get into physics class, you're going to get into these much more depth than what we're going to do. So concave lens, kind of like its name suggests, has the concave shape to it. And the concave lens really will spread light. So as the light wave enters the lens, it's going to be bent. And again, you can see this concave shape here is going to cause the light rays to scatter. So it's going to come in, and these light rays are going to scatter. Concave lenses there's many different types of lenses. Think of a telescope, binoculars, your lenses in maybe in your camera is a combination here. So a concave lens, you have the spreading out of the light waves. The spreading of light waves. The other type of lens, and that is a convex lens. Convex lens, you think the lens in your eye is really a convex lens. And these are the ones that bend out a little bit. And a convex lens, kind of neat thing about these, as the light enters into it, you get some magnification. Magnify. Think of your magnifying glass. And The other thing is the image is upside down. And the image is inverted. The image your lens in your eye puts on your retina is inverted. It's your brain that flips it back up. So a convex lens, they bow out, and you can see, right here. And the big advantage is the magnification. Your magnifying glass. When I was a kid, we used to try to burn ants. The magnifying glass, all that kind of fun stuff. And the image is inverted. Your microscope's got magnifying or convex lens in their telescopes. Many of these different optical instruments have a combination of many different types of lenses, but these are just a couple of the basic ones. So that's it for this one. On the next one, we're going to look at the Doppler. We're going to look at Snell's law, and then the last one in this series is going to be the Doppler effect.